Okay, but the nice thing of having a function is it allows you as in the caller. So when we define it, we're not calling it yet. It is static. It is not printing out anything. It is not adding up anything. That's just defining, telling Python, I want you to be able to do this when I think the time is right. That's when you call this function. Okay, so we have defined these steps, ask Python to remember it, and this chunk, rather than calling it some digital number like x5329, we call it a human readable number, a name called add them up. Now, of course, this feature of naming it in a human readable way is a very important feature as well, because one of the goals is to make your code readable. So if we show any other programmer, if they are skilled enough, they probably will notice certain pattern like that, but it still takes a bit of seconds and time to notice it, and still you're not very sure. You're guessing that 90% of the chance that, yeah, I think the original writer wants to repeat this code. But here we are making sure when you functionalize that segment of code, you are very explicitly informing everyone, including yourself, your future self, I like to call it, that you are actually reusing the code. And it is so specific that it's from here to here, right? Lines 29 to 32. And the functional mechanism in Python also allows us to pass in data. It'd be quite cruel if we are just required to rigidly repeat this. That will be more like a for loop or while loop, right? But we are able to, every time when we call this logic, give a different input data for it to start running. So for example, one of the very important number is the 2 here. We would like to change because boss may say add up 10 ones now, add up 10 sevens now, and we can't predict what the boss wants, right? So we want it to be flexible. Uh, um, so we'll just say a number, and we change it to number. So notice that now we have a very powerful function because it can handle any number that the boss gives. Not just adding up ones, not just adding up sevens, but any number the boss cares to suddenly throw at us, because the boss also doesn't know what COVID-19 wants to throw at us, right? So if the boss were to say add up 117 10 times, well, you can just say add them up 117, and that's it. Because the internal logic is the same. Start with clearing up the accumulator, run for 10 rounds by adding the whatever number is given to me to the accumulator as many times as 10 times, right? And then print out the result. So now we can do this. Boss says add up 7 10 times. Very simple. We'll just say that, well, y is equal to add them up 7 and then print 1. Okay, so what happens now? Well, 70 as expected. Then suddenly boss says, oh no, COVID-19 second wave is coming. And this time we have changed the code to 927. Can you add up 10 times 927, please? No problem. I'll just add them up 927 and then run. Finish, right? Oh, well, I should be just calling this because notice that I'm not returning the number, I'm printing out the result. So the function directly prints out the result. I don't have to print it again. So I should change how I call this function. Okay, so when I do that, it will now no longer print the none because the result returned from add them up is none. All right, the value returned from add them up is none. We'll talk about return values in a while, but here I'm just activating this robot, right? This function called add them up with the value 927, and it correctly prints 10 times of 927. But look, we still have a number that's fixed in there. As long as there's a fixed number or a string or a fixed constant, the feature or the performance of the function will be locked by that constant. So for example, we have a presence of 10 here. So that means that the performance of this add them up function is going to be always repeating for 10 times. Agree? Right? But then we could also make it change depending on the caller's circumstances. So for example, second wave of COVID-19 hits and the boss says, oh, I need you to add 927. Wait, not 10 times, but 15 times. Well, are you going to write a new function called add them up 15 and then number and then repeat everything? You get the idea, right? Why don't I just say how many times, right? And if you say 10, I will repeat 10 times. If you say 12, I will repeat 12 times. And hey, look, the logic is being distilled out. We only now see the soul. We don't need the flesh, which will come later when we call the function, you see. So we see the soul, the skeleton that makes up the whole logic, but there is, by itself, without data, it's not meaningful. So when we just fill in the data later, all right, we can activate the function and flesh it out in literal. So now I got to retrospectively pad them up because it was before this understood as 10. But now it no longer understands, right? So it is how many times. But there is a way in Python to say, well, you don't have to specify if it is the standard number of times because your old code that was tested thoroughly and correctly didn't use the comma 10 convention, right? Comma how many times? It was assumed that the standard number is 10. So in Python, you can say something like this. This second number is how many times to loop. I think we understood that, right? Yeah. But we can also say by default, this input variable has the value 10. If the caller never specifies, as in this case here, add them up 7, then assume that in my logic internally in the function, this how many times is automatically set to 10. That's cool, right? Because we want that. However, if the caller did put a 7, 12 instead, that means the 12 will overwrite the how many times equals to 10 and make how many times equal to 12. And then we'll repeat 12 times instead of 10. Let's try that out. So for now, even though I've specified the second variable, but because of the equal to 10 default value, that means if you never overwrite it, it will be standard. It will be 10. This calling convention is okay. So we can say add them up 7, add them up 927. And it'll be okay. We'll still get the results. But if you did not specify equal to 10, Python expects the caller to fulfill as many input requirements as needed by the function definition. If you didn't fill up, as in this case, I expected 2, but you give me 1, Python will complain with a runtime error and say, well, I need 2. I need 1 more. Call how many times, but you didn't give me. Okay, so let's just put that back in, and we saw how this ensures this modification, this upgrade of the function, being able to now add beyond 10 times to 15, 17 arbitrary number of times is now backwards compatible. That means we don't have to comb through our 500 gazillion files for any occurrences of add them up and then put a kind of a useless comma 10 all through. We don't need that. We just run as usual, right? So, but for newer codes that are written after this upgrade of comma how many times equals to 10, we can always say add them up. 968, boss says add up 968 17 times. And this will work because the 17 will overwrite how many times here, whose default value is 10, and overwrite it to become 17. Okay, so far so good. Okay, so you see that this addammer is really getting more and more powerful. It's almost like it's able to do anything now, so long as we give it more and more data and guide it how to do. Yes and no. We don't want functions to be so fanciful as to become one function for one application. That means the whole application is within one function. This one function is too multi-talented that it is begging for more segments of its code within it to be functionalized, right? So having a function that does a whole suite range of things like reading from file, doing analytics and printing out results and asking user what else you want to do, and then writing the file back in and emailing the user and so on and so forth within one function is not the point and is not a good practice. Functions need to be very focused. It can have slight variations of the logic, but it needs to do so-called one thing, one main theme of things very well and very logically and very reusably. All right. So that's a quick demo, sort of going from a scratch idea of adding 10 times to a more complicated example of adding any number of times, and trying to work it out using our plain old loops and finding that it's not adequate and realizing that maybe we should use functions. In fact, that's why functions are so important. Without it, our code will look very messy. It may work, but it's very expensive to maintain. Imagine that every time you search Google, Google charges you $1. And for each result, you are charged 10 cents. For 100 results, you're going to be charged uh, how much? $1, $10. That's so expensive, right? Because it's so hard to maintain the software this way without the functions. Yeah. So a lot of results, a lot of economical consequences can follow if we don't have good mechanisms for abstracting the logic out from the data. Okay, so let's come back to our sort of a classroom setting here, where we want to talk about what is y function, right? So now I think you have a story to go to fall on to think about why we need functions. Now, function seems to be that it has to be complicated code. That's not really true. That's not really true, because a function, so long as it does one thing very well and is very and it may be it's not a requirement that it is always being used more than one time. It may be only a one-off function call. We call our own function one time. That's almost like, why do you need a function, right? You might as well just copy and paste the whole code here, and we see that it is not necessarily just repeating use or reusing the logic. We can also make the function, um, our code, basically a lot more readable. So for example, we may have a code like this. Let me just get to my screen space. So let's open up a new file.